Let's do more logarithmic differentiation. So once again, when do we use logarithmic differentiation? Number one, when the function is in a factor form, like the yellow one, so y equals to x minus 1 raised to the 10 power, and then you multiply a couple more factor raised to a very large power. So for logarithmic differentiation, once you take ln on both sides, you can split up the multiplication and bring the power down. And then another typical example is you have a rational function. So once you take ln on both sides, you can split it up into two ln, one minus the other, and then you can bring the power down. And then take a look at the orange function. So once you take ln on both sides, you can bring the complicated power down. So I will be thinking about three case scenario. Number one, rational function, a factor raised to a very large power. Number two, multiple products, each product is raised to a large power. Number three, the power, the exponent is very complicated. All right, so the first step to do logarithmic differentiation is you ln both sides. Okay, so when you ln the right hand side, do you see this? If you have ln A divided by B, that equals to ln A minus ln B. So let's apply that to the right hand side. So we have ln y equals to ln the top, 3x squared minus 1 raised to the 8th, minus ln the bottom, which is ln x plus 1 raised to the 1/2 power. All right, so once let me emphasize that we haven't done any differentiation yet. I just took ln on both sides, and then the next step, you will differentiate both sides with respect to x. So that will be d dx, the left hand side, equals to d dx, the right hand side. Okay, let's put this down. So this is ln y, and then the other side is ln 3x squared minus 1. And then by the way, so since we have 3x squared minus 1 raised to the 8th power, so using power rule of ln, I can bring the 8 down to the front. So this is 8 ln 3x squared minus 1 minus 1/2 ln x plus 1. Alrighty, and then this one left hand side, what do? We use implicit differentiation. Write it down, implicit. So implicit means the derivative. What is the derivative of ln? That is 1 over, right? So that is 1 over y, since this is with respect to x, but you have a y as an independent variable, you have to mark this dy dx at the end. And then the right hand side, you have the derivative of ln. So for the ln, you immediately bring the function to the denominator, 3x squared minus 1, and then the derivative of 3x squared minus 1 is equals to 6x, right? 6x, and then of course don't forget that you have the 8 on top. So you have the 8 on top, and then the other one, so you have a 2. Immediately bring the x plus 1 to the denominator, and the derivative of x plus 1 is equals to 1. And then the next step, you have a dy dx, and then you multiply the y to the other side, so you have a y, and then you multiply, so 8 times 6, that is 68, right? Divided by 3x squared minus 1, and then minus 1 divided by either you say 2x plus 2, or you leave it like that. So you can say 2x plus 2, and then what is the y for? What is the y equal to? So look at the very beginning. I gave you that y equals to a rational function, right? So that is what you have to put to the y. So one thing that I always do is I'm going to copy this, and then I'm going to paste that right over here. So to replace the y, I am going to erase this and then put this over here. So I'm going to copy it, copy, and then paste. So that is what you need to replace the y with. Okay, so let's make the equal look a little bit better. So that is equal, and then this is a multiplication, right? So let's put a dot right over here. So now let's check. On the left hand side, we have a dy dx. dy dx means a y prime. Some textbooks prefer to use y prime. And then on the right hand side, there are no y, right? The right hand side is just all x. So this is my final answer. Okay, box that. This is done. All right, moving on to the orange function. So the orange function, we have y equals to x raised to a very complicated power, right? ln 10 plus x squared. I don't care how complicated it is, because the biggest purpose of using log differentiation is you take ln on both sides and the benefit shows up immediately. Do we agree that once we take the ln on the right hand side, we can bring the power down? I don't care how complicated the power is. I don't care what variables you have. All you have to see is there is a power. You take the ln on the right hand side, then you bring the power down. Okay, so the next step is ln y equals to bring the power down. So you bring the power down, that equals to ln, and then 10 plus x squared, and then you multiply ln x. So now we are ready to differentiate both sides with respect to x. So that is a d dx the left hand side, and then d dx the right hand side. So that means differentiate both sides with respect to x. So this is ln y, and then this is ln 10 plus x squared, and then ln x. So the right hand side is definitely a product rule. There is no way to escape that. The product rule is fg prime plus gf prime. So this is product rule. Okay, and then the left hand side is an implicit, right? So this is an implicit differentiation. The derivative of ln y is 1 over y. Since this is with respect to x, then you have to leave a mod dx dy. I mean dy dx, sorry. dy dx, which is a y prime. And then the right hand side, so the product rule, okay, g prime, the derivative of ln x is 1 over x, right? So you copy f, 10 plus x squared, and then 1 over x plus g ln x, the derivative of f. So you bring that to the denominator, 10 plus x squared. The derivative of 10 plus x squared is 2x. So we are almost done. And then we have a dy dx equals to y, right? And then we multiply. So we have the x in the denominator, and then ln 10 plus x squared. And then we add 2x times ln x divided by 10 plus x squared, close the square bracket. And then are we done? No, we still have a y on the other side. So I'm going to copy this and then bring it down. And then I am going to erase the y, and then what do I put? What is y equal to? Look at the very beginning. Do you see that y is equals to x raised to a very complicated power? Or you look at the given problem. So that is y equals to x raised to ln, and then 10 plus x squared. Close the parenthesis, and then this is done. So let's box this. Here is your final answer. Okay, make the box bigger. There you go. Again, dy dx is the same thing as y prime. All right, so let's move on to the last one. The last one we have this. I'm going to write down the problem for you, so you don't need to rewind the video. Y equals to x minus 1 raised to the 10, and then x minus 2 raised to the 20, and then x plus 3 raised to the 30. Okay, so first of all, we ln both sides, so we have ln y. Actually, you know what? I prefer to do this in highlighter, so you then distinguish the difference between the original problem and the ln. So x minus 1 y, and then this is a x minus 1 to the 10, and then x minus 2 to the 20, and then x plus 3 to the 30, right? Okay, what's next? So you have ln, a product times another product. So you can split it up as ln, and then x minus 1 to the 10, plus ln, x minus 2 to the 20th, and then plus ln, x plus 3 to the 30th. The other side is just an ln y. What else? And then you bring the power down, right? Okay, let's bring the power down. How about this? I'm going to save a line for myself. I'm going to just erase the power and then carry it to the front. So this is a 10, this is a 20, this is a 30. So now we do not have any more big powers anymore. Now we are ready to differentiate both sides with respect to x. So this is a d dx, the left hand side, and then equals to d dx, the right hand side. Okay, so let's use the technology. I'm going to copy and then paste. There you go. I am going to copy this and paste. There you go. Of course, we need a little more space, right? Okay, erase that, then paste, and then close the parenthesis, and then we can get rid of this. Okay, derivative. Left hand side, what do? Implicit, right? 1 over y, and then dy dx, and then the right hand side, bring the x minus 1 down. The derivative of x minus 1 is 1, so you have a 10 on top. And then this similar, right? X minus 2, you have a 20, plus x plus 3, you have a 30. And then you move this over, dy dx, that is equals to y times what? Y times this. Copy, and then paste. Y times this. And then what is y equal to? Y is equals to the original problem, right? So you are going to copy this and then move that over here. So that is equals to, let's get rid of that. Then this is a x minus 1 to the 10, x minus 2 to the 20, and then x plus 3 to the 30th. And then this is the final answer. All right, so is that helpful? Do you like it? If so, give me a like, share, and subscribe. I will catch you all next time. See ya.